But we had to arrive at the optimum compromise between electrical performance and minimizing friction.
Yeah.
So we've arrived at what we believe is a very low friction arm, but which also has decent conductivity. The thing is, if people come up and say, is it silver or copper? They're missing 30 other factors, at least.
Right. You could probably find good connections and good cables for balanced or single-ended with the Tonearm. They're pretty even match. Really, this debate might be a lot more about the electronics that it's going into. As you probably know, we're Tonearm manufacturers. We get questions all year round about whether people should use copper or silver, or whether they want a continuous cable or a jointed cable. What people don't ask us, and what I'm often explaining, is that in Tonearms, cables add friction. They're mechanical parts. They're part of a mechanical device. And the most important thing about a cable might be nothing to do with what's listed in the specifications. So today we're going to be exploring some of the more physical attributes of the cable in a Tonearm, as well as talking about its electrical performance, how that affects sound, and also we're going to get a little bit into the single-ended versus XLR debate. Let's get into it. Hi, I'm David Baker of Origin Live. This is Mark Baker, my dad, and our company founder. And today we're going to be looking at cables. We're going to start off by looking at the kind of mechanics and the friction of the cable, onto shielding, then through to electrical performance and connection types. Now, what a lot of people might not know is we actually started out in cables. Origin Live was not always called Origin Live. In 1986, we were called Cable Design, which was a very creative name for a company. But one of your first products was a cable. Can you tell me a little bit about that quickly?
Well, very quickly, was just leaving my occupation as a shipbuilder, and I'd become a hi-fi enthusiast in the previous year, and I've been experimenting with different types of cable, because in those days solid core was all the rage. Everyone was going over to solid core mains cable, but there'd been no one was making a hi-fi solid core cable apart from a company called D&M, and they made a very thin, spindly solid core cable. So I came up with a design which was basically combining a thick wire and a thin wire, well, 3 thin wires, which was the very first thick-thin combination. Nobody else up to that time had thought about combining thick wires with thin wires. Numerous people now use that idea because it is a valid idea. We don't always use it, but it's still a valid idea. So that's how I started.
And then we became Origin Live, equipment racks, then Tonearms, modifications, and then the rest is history. 40 years on. Okay, so through to cabling and its application in Tonearms. One of the things I'm always talking about when people ask about why we don't use a continuous loom, is I'm always explaining about friction. How the cable actually adds friction to a design that we want perfect freedom of movement, but the cable itself can inhibit that.
Yeah.
Okay, so can you talk to me a little bit about that?
Oh, absolutely. Yeah. I mean, just to illustrate this simply, this is the thickness of an external cable that we use. And as you can see, it's a lot thinner than the internal cable. So the internal cable has to be thin for the simple reason that if it's thick, you get such a high level of arm friction that the arm will literally skip over tracks, because it's got such cable resistance both in the horizontal motion and the vertical motion. I mean, we started off life with rewiring Riga Tonearms, Alphason Tonearms, numerous Tonearms, and we would get arms sometimes which, because rewiring arms was quite popular in those days. I mean, we must have rewired hundreds and hundreds of Rigas because we had a better cable. And we'll go into that later on as to why our little thin Litz wire cables are electrically very good. So we rewired all these arms, but sometimes we'd get arms where someone had tried to do a DIY job on their arm.
Okay.
And they'd just kind of stripped down an interconnect cable and threaded it through. And of course, it was so stiff that the arm ceased to function properly, and they couldn't figure out why. Because I mean, it would function, but it would skip records, and so they'd send the arm into us to do the job. But we came to the conclusion. Oh, the other thing that the real question: why not use a continuous wire? The simple answer is that electrically, you need more than a thin wire. Now, I know if you just look at theory and that, it shouldn't make any difference, but subjectively, it definitely makes a big difference. For a good external wire, you don't use a spindly little thing like that. You use something more substantial.
So maybe we should get to the kind of fundamentals of how this all looks inside of a tone arm. So you've got the cables on a typical design, probably like 95% of a design. VPI would be a slight exception. But your cables running through all the way through the tube and then through the axle. So they need to go through a bearing, because the bearings are hollow, so they have space for it to go through. And then, so what you just said about you don't want to use thin wire all the way through. You'd have your thin, flexible, low friction bearing, low friction cable going through the tube. And then once it's gotten past the bearings, that's where you want to join it up to something a bit thicker?
A little bit more complicated than that.
Okay.
And don't forget that some arms actually sprout the wire.
So the VPI just completely circumvents
quite a number of arms do that. High performance wire. We actually, people have this thing, mechanical joints in a tone arm are not great. Solderable joints are a lot better. But no joint surely is the best. And the point, the
which
problem,
would be continuous.
Problem with that argument is that basically we have experimented with this endlessly, because there was a wire called the incognito wire, which was a good wire, but that was a continuous wire. And we experimented with, continuous versus best type of wire you could use on the external and the joints, even with 5 din-pin joints. Using the better wire far outweighs any advantages you gain by having a joint. Okay, it's just simple as that. It's massive. And I would also add that we actually try and minimize joints, but because of the fact that the better tone arm wire is very important, on our top arms, we actually use a significantly thicker wire than the normal Litz wire we use for the flexible part of the wiring, which has to be flexible and low friction and all the rest. So in say that length of the tube, we'll be using thicker wire because it's an advantage. Sounds better.
Okay. We were talking there about friction. Is that adding friction to the bearing because it's like too thick for the bearing, or is it because it's twisted in a certain way around the bearing, or the bearing is twisting where does friction come into things?
Well, good question. The easy illustration, it's because of the amount of metal in the wire. If you think about it, and I always like to think of extremes. Just say you had a bit of mains solid core cable going up through there. It is very resistive. Okay, you'd have real problems just bending it round.
So actually,
it's just
not going to twist.
Yeah, the copper is not going to twist, and neither is going to bend very well. So it just adds an awful lot of friction. In fact, I remember Paul Miller had a discussion with Paul Miller, who tests tone arm bearing friction. I said, look, Paul, you won't be testing the tone arm bearing friction with our arms because the cable has far more friction than the bearings. Right. It's as simple as that.
Yeah. Bearing friction is an interaction of a few different factors. It's not simply the bearing. You also could think about side bias, unless you're measuring without side bias or, whatever.
Side bias adds friction.
Yeah. Especially if that mechanism is something like a spring-loaded, where it's never...
Yeah, that's the hardest of the lot.
It's never really
You're rooting it to the ground. And
it's never truly off, is it?
Yeah.
Okay.
One thing that's worth mentioning here, and it may sound fairly obvious, is that because we have optimized the internal wiring at where it actually bends, because it's a very critical thing to do. And I in the early days, I experimented endlessly with all the different types of idea to minimize friction because if you go for a lot of thin strands, it actually bends more easily than if you have a small number of thicker strands.
Right.
So we optimized the electrical performance because the thicker strands tended to sound better. You got a lot more bass weight in the sound, for instance.
Okay.
Some tone arms use very spindly wire to reduce friction, but we had to arrive at the optimum compromise between electrical performance and minimizing friction.
Yeah.
So we've arrived at what we believe is a very low friction arm, but which also has decent conductivity.
Because you want the best of both worlds, because obviously,
You do, yeah.
Some of the potential solutions to get low friction will inhibit the electrical performance and vice versa.
Yeah.
Very interesting. Okay. And just besides friction, one of the things I'm aware of with the VPI is that you twist the cable more to add side bias. I think we were talking about it in the last one. And often cables are twisted in order to reduce crosstalk. Is the actual kind of twist and do you call it a loom? Is it called a loom?
Yeah.
Is the loom of the cable also a consideration here?
Well, yeah, it is. I mean, all these little details are phenomenally important. Because, why do we bind the wires with a special coating? It's PTFE tape.
Very special coating.
It's an absolute nightmare to wind this stuff.
Yeah.
It takes, I wouldn't say years of training, but it takes a lot of training, because you've got to bind this so tight. Because if you go thick, the friction and bend suddenly increases. So we have a dimension, mustn't be larger than 0.9 of a millimeter or something for the thickness here, because it really matters. So that's what we do to try and reduce the friction. We did experiment. I mean, when we first started off, we just used to have the 4 wires coming out loose from the wire, which is what many arms do. They're usually PVC coated, Teflon coated, whatever. But that increases friction. If you actually bind them together, it reduces friction. But it is an art form to get that right.
Yeah. So
you can end up if that tape is too thick and it's not wound very precisely, you get an increase in friction.
Yeah, another area to be super careful with in terms of.
Yeah.
Okay. I'm just spitballing here, but does the cable ever add an inward drag naturally?
Yeah, that's a really good question. We found that the best thing to do is to when we first manufacture the arm and we put in the arm base. Mel, who's the person who makes Mel and Lloyd who make these arms, always try and optimize it so that with no side bias on at all, and they get it so it's swinging freely. The arm is just freely. So that with no side bias or anything, the arm is at its neutral point, roughly halfway across the record.
Right.
And so you get sometimes a little bit of swing in either direction. But it's much smaller than the side bias force itself, and it's just an inevitable consequence. Yeah. Unless you go to super thin cable and you can say, oh yeah, we've got no side twist on our arm cable at all, but the problem is you would end up with a lower performance overall.
Yeah.
Everything is a balance.
Is that because you do want some level of inwards drag, or you don't? Because I think JR of Wally Tools, you were having pizza with JR a few weeks ago. In Vienna. So he says you actually want it to stay basically still in the middle of the record, and that means that it has a low horizontal torque.
That's right, yeah.
Is that correct? Okay, fundamentally, do you want the cable to add any torque to your design at all?
No,
or none?
not really.
As little as possible?
As little as possible.
Yeah. Okay.
Yeah, it's all friction and feed through at the end of the day.
Yeah.
You're feeding vibration into the arm.
And anything that's going to compromise freedom of movement will compromise the sound.
Yeah.
Very good. Okay, next up, shielding.
Okay.
So how important is shielding with these wires? Because obviously, every arm cable that you'll see, we've got these little bits here. Oh, they're unshielded. Compromise. Is it also unshielded as it comes through the arm tube?
Well, it depends on the arm tube. If you've got a metal arm tube like the ones we use, then it is shielded. Carbon fibre, not so much, but it is shielding. And wooden tubes, they're not shielding it at all. Having said that, it's not a complete disaster. I mean, the Schroeder arm was a very, very good arm for many, many years, still is, and that used wooden tubes. So you do get a little bit more electrical noise and hum coming through, but it's not that great.
And I think one of the interesting things you were talking about when we were kind of planning what we were going to say is it's far more important. It all matters, and it's good to have your arm cable, the internal shielded, but actually this is a very small amount of cable. It's almost more important to have really good shielding on your external. Is it more important or less important? Or?
Well, I'm so glad you remembered that, David. I'd forgotten to mention that. Yeah, no, shielding is so important, isn't it? Because basically, this is only 240 millimeters. You've got virtually 5 times that length in your external cable, and that's where you would start to pick up stuff. I mean, even on an unshielded 4-inch part of internal unshielded cable, you can pick up radio stations if you really whack the volume right up. You can I've heard radio stations coming through the speakers. You can barely hear them, but you can just hear the noise. So noise is not a good thing. And if you have a really black, silent background, it just helps your hi-fi, because this stuff interferes at a level which is...
you want a low signal to noise ratio.
Yeah, it's bad news, basically.
The other thing that springs to mind is your external cable is actually, in terms of the hi-fi equipment that it has to go near, it's going to be closer to transformers, things that probably have... depending on how well shielded they are, but some transformers aren't very well shielded at all. And it's good to have that as shielded as possible. Yeah. Okay, so I know that there are some tone arms that choose to earth through the RCA plugs. They don't necessarily have a separate earth at all. Why would you go through the RCA as opposed to have something separate? And maybe what are the other earthing considerations with a tone arm?
No, I get it. I'll try and answer a very, very knotty issue in a simple way. Riga arms actually don't have an earth wire. They don't have a separate earth wire as such, because what they do is, well, first of all, to earth your Faraday cage is a good idea, because theoretically it drains all that RF that's being picked up.
Yeah, because this is an antenna, essentially.
It drains all that into your earth. The problem comes, and this is where it gets knotty, is that if your earth becomes so polluted, then it can go the other way, and you can start feeding RF into your shields and so on.
So, and the shields are, just to be clear, the shields for a tone arm share the same earth as the cartridge. Is that right?
It really depends on the setup. It can do, yeah. And this is where, as I said, it does get knotty, and it depends really on your preamp design. Some preamps have what you call a floating earth, and I can't go into the details here.
Let's not.
But it is different to where the circuit is grounded to real earth. In other words, your mains plug has a real earth coming out of the mains, and in other words, a floating earth is not a real earth. So your tone arm signal is going into that, and you need to have a separate earth. On our cables, our upper cables certainly, we always have a separate earth.
On all of our cables.
On all of our cables.
Also on our Riga, on the rewiring we do for Rigas, we provide a separate earth. Yeah.
We provide a separate earth, and that earth's the whole arm tube basically from start to finish.
Why have a separate earth?
Because if you do what Riga do and you put the earth onto the return signal wire, you are effectively polluting the signal wire with what's in the earth. And as we discussed in a very different video about ground noise, that's not necessarily a great idea.
The earth is not a very clean, pleasant.
It's not. No, they're not like they used to be 40 years ago. Put it like that.
Yeah,
they're full of electrical pollution. Yeah, so we have that, and then because of amps being designed very differently and the amount of filtering they put on the earth and goodness knows what. We supply a solution which basically covers all the bases. So we have 2 wires here, which are the earth, which earth the shields. Okay.
For the cable.
For the cable, yeah. Now, some people find they're best left disconnected, or it makes absolutely no difference whatsoever.
Generally, I find that it lowers the noise floor.
Yeah.
With our amp, with the aesthetics that we use.
And then we have a 3rd wire on the end, which is a signal earth. And this is connected to the signal return. So that for some situations, if you've still got hum after you've connected all the other earths, so you've still got hum, try that and it may work.
I've never personally used that one.
Yeah, there have been instances where it has worked. So that's why we include it. But it gives you all of the options then.
Yeah, especially if you're going to change your amp in the future or something like that.
Yeah. By the way, before we move on from external cables, we do actually offer our cables to the wider world. So anything with a 5-DIN pin plug, you can use our cables, and they do make a phenomenal difference. We know our cables outperform stuff at 10 times the price on the market, and they will give an upgrade, massive upgrade to a normal conventional arm. We offer it with a money-back guarantee, so you can just try it. If it doesn't work, just send it back for a full refund.
Yeah. I think what somebody pointed out the other day was that none of our cables really go to exorbitant, heady prices that some do. Our top of the line is £1,200, which some, I totally understand that some people would bulk at, but in terms of how high you can go to spend on a cable, our entry level cable is around 100 and something.
Yeah, and in the context of a high-end system, I remember one person who put our cable into his SME5, and he said it's the biggest upgrade he'd had. Massive upgrade.
Wow. He needs to try a Tonearm. Okay. Hi, I'm quickly interrupting this video just to ask that if you're finding it worthwhile, please could you hit the like button, subscribe to the channel, and also press the bell notification. It really helps us to carry on making these videos. And what we want to do is carry on having open conversations about vinyl replay, and also giving you insights into how we've been making turntables and tonearms in-house in the UK since 1986. Well, not me personally, because I'm 31, and that's... Anyway, you get the idea. So thanks, and back to the video. So getting into the more murky waters of cable, which we just started talking about in terms of some of the heady prices out there, let's talk about electrical performance. We do believe that cables are different. I'm 30 years old. I have no big investment in this, but I believe that there's a difference, an audible difference between cables, and this comes from listening to cables. Maybe let's begin talking about copper versus silver.
Okay, I think we're on such a dangerous area here. We're going to get a lot of hate mail for this.
Yeah, I'm hoping we won some of you over by talking about, just physics, but this is going to be all subjective. Okay, so where do you want to kind of start in terms of talking about electrical performance? With the material, or with the gauge of wire, or the connectors, or...
Okay, well, I could start off at the very beginning, really, and that is that we were recommended to use Litz wire for the internal wiring.
Okay.
Worth mentioning that wiring in a tonearm is actually probably more important than most areas up the chain, for the simple reason that the signal level is 1,000 times less, at least, than your CD player or your streamer is kicking out.
4,000,
Yeah, so any slight problems that you're getting is amplified 1,000 times, which is huge. So the cable is very important, and the audible differences are very significant. So anyway, we started off with using Litz wire, which is, and just better explain Litz wire to people who haven't heard the term before. But with a normal wire, you've got countless strands that are all twisted together, all right? And a Litz wire, and these are all copper, so they're free to conduct across each other.
Okay.
And the problem with this is that the electrical signal can jump from strand to strand. So it'll go like this. So as the strands vibrate, and they do in micro vibration, they vibrate very minutely. You've got this going on, and that creates some form of noise, and it's perceived in the sound quality as a kind of graininess in the sound. In other words, instead of hearing clear, natural female vocal or male vocal, it's got an electronic artifact sort of pasted over the top of it.
Okay.
Now, Litz wires overcome that problem because what they do is they insulate. You just got to imagine all of these wires are insulated with a thin enamel, and there's no electrical contact between them whatsoever. So the signal simply passes cleanly, and there's no side-to-side chatter going on. So anyway, after a lot of experimentation with various thicknesses of wire and how many strands you use and so on, we arrived at what is a fantastic Litz wire. We also cryogenically treat them so that you get the maximum. So that's part of the story of the internal wires.
What is cryo meant to do?
Well, it de-stresses grain boundaries, and there are microscopic tests, not microscope tests. You can take pictures at very high magnification of grain boundaries in the copper, and before and after cryogenically freezing. And there is a de-stressing that goes on, which does result in a much less grainy sound in the music. I mean, it's costly to cryogenically freeze stuff, and if it wasn't effective, we certainly wouldn't do it. Okay, when it comes to external cables, things get a bit more complicated because we use a coaxial cable, which is basically the outside conductor. It becomes a shield for the inner conductor. And we have had instances, I mean, we only used coax cables in the early days, but on the lower arms, we use coax for cost-effective reasons, really. And it's still a very good cable because a good, well-designed coax cable is still a very good cable. The slight complication used to come with people that had balanced amplifiers, because they'd say, we want a fully balanced cable, because the cartridge is obviously, the output from the cartridge is ideally fully balanced, and you've got a balanced amplifier here. And what we found is that we'd say to people, look, a well-designed, and this is true, a well-designed coax cable is going to sound better than a poorly designed balanced cable, because there are a lot of balanced cables on the market that actually don't sound good in Tonearm wire at all, because they're designed for a signal level that's 1,000 times higher, and they subjectively just say have too much bass for one of the things they tend to exhibit. So we would use coax wire on both for balanced amps and unbalanced amps, and it works absolutely fine. I mean, what a lot of people, just to digress a little bit, what a lot of people don't realize is with a balanced output from an amp is that often the speakers that they're putting it into are highly unbalanced. They've got a massive inductor on one side of the driver and nothing on the other. So balanced goes, a lot of the balanced ideal is designed, well, the PA industry in particular uses it to reduce noise, incoming noise along cables and the like. But there are also internal advantages to balanced, and that's where you get the advantage of a balanced amp. Although that's arguable and controversial
and
we'll
get a little bit more onto that a little bit later. So the upgrade cable that we use is coax.
Yes, up to the illustrious.
Okay, and then we use our silver hybrid cable.
Yeah.
So what is the silver hybrid cable in terms of, if it's not coax, what kind of cable is it?
It's a mix of, and some of this is confidential really, but it's a mix of silver wires and copper wires. And
I mean, that's kind of obvious from the name silver hybrid.
yes. Not necessarily, because you can have silver-plated copper. A lot of companies use silver-plated copper wires.
Right, okay.
Yeah, and I wouldn't be averse to using pure silver wires either, because what I found over the years is that people associate silver with a bright, sometimes harsh sound. Okay, and it can be. It
Yeah.
really can be like that. And I wouldn't touch that kind of silver wire with a barge pole. But some silver sounds fine. And the reason is because it's been properly annealed.
Okay.
And we first got onto this when we were designing our own silver wires. And we found that from one company, the wire came off the reel all springy, like a spring, you know.
Right.
It'd go boing, you know.
Okay.
And the other wire, it all just came off perfectly dead. And which wire sounded the best? The dead one, because it had been annealed properly. Vast difference in sound quality. But there are a multitude of factors. You've also you then move into things like what sort of insulation should you use.
And if you had a choice between copper and silver, just copper, just silver, which one would you go for?
I think the mixture is the best.
Okay.
But I'm not a well-designed silver-plated copper wire can sound really nice. There's so many factors that go into a wire design, and it makes, you know, the thing is, if people come up and say, is it silver or copper, they're missing 30 other factors at least.
Right.
Because the strand thickness alone has far more influence than whether it's silver or copper.
So you're thinking about the gauge, you're thinking about whether it's been annealed well. What kind of other factors are there to think about with this type of cable?
Well,
anything else that you can
the insulation
divulge?
is the most obvious one. So you've got PTFE, which is rated as supposedly very high. What PTFE does, it tends to give you a wonderfully transparent midband, but the bass is often lacking. It doesn't have a good tonal balance. In other words, it's got transparency, separation, purity, but it doesn't have a great tonal balance. Depending on how other things are designed as well. And you've got PVC, which is meant to be the cheapo solution, which is actually very good tonally, not so good when it comes to transparency. And then you've got cross-linked polyethylene, which is my number one. I think that's the best. In fact, if you look at a lot of the best wires on the market, you'll find that's what they're using.
Okay, you heard it here first.
I don't think so. I don't think so somehow. But there are more exotic things like, in terms of aligning, people know that burning in cables, there's various devices to burn in cables. And we find that our cables used to take something like 100 hours to burn in. And then they would suddenly click from being mediocre to fantastic, which is, I think it's dependent on the cartridge you're using, because if you're using a cartridge which has a higher voltage, higher millivolts going through it, higher ampage going through it, it'll burn in the cable more quickly. So it's dependent on a number of factors. But either way, you've got this, we know that burn-in does work. And we'd recommend people run. We have a burn-in cable that you can just basically hook up and run a CD player through your Tonearm cables.
Yeah, it's
never plug it into your phono input or it'd blow it up instantly. But burn it in first, and then you'll kind of be halfway there straight away.
And you're saving playtime, record wear, all of that kind of stuff.
But there are other tricks and things like instead of putting 1 volt backwards and forwards through the cable, put 100,000 volts down it. Use a Tesla coil to fry it.
Yeah, wouldn't that fry it? Would that fry it?
No, not if the current is low enough.
Oh, okay.
But there are lots of other tricks and things in the way that cables can be treated.
Okay, so moving on to something that we were touching on earlier, the big debate, maybe the most controversial thing, not controversial, but the most arguable thing that I'm expecting in the comments would be single-ended versus balanced. So should we use RCA connectors or XLR connectors?
Right, okay.
Because obviously, like you say, the signal's balanced. XLR is a balanced connector.
Yeah.
Surely this will be lower noise. Surely lower signal to noise equals better sound.
Okay, there's a couple of arguments in here, and I think to cut a long story short, whether you use balanced or unbalanced is up to the electrical equipment you're using, the amp. So I don't want to get involved with that debate here because it is a different debate, but obviously people use a balanced amp because they're persuaded that's the way to go. It has absolutely, well, very little to do with the Tonearm cable that you use. It's going to be the same wiring configuration, basically. So then you're asking about whether you should use an XLR or a phono plug. The XLR plugs, you usually have no choice. It's just an XLR input and that's it. So you have to use an XLR plug, and we provide them. There's no problem fitting an XLR plug. There are some very high-end phono stage manufacturers that don't use XLR plugs. They prefer to use an ordinary RCA plug, and they have a separate earth to wire your earth onto.
Well, I mean, most phono stages out there are going to be RCA only.
Oh, they are, yeah.
It's more difficult. It's becoming a little bit easier, but it's certainly more difficult to find an XLR balanced configuration. But also to say, on this whole debate, we make XLR balanced tonearms. We've used balanced tonearms. We've used balanced tonearms in balanced systems. We've used, generally we'll use fully single-ended systems. I think we're currently using single-ended because we have a very, very good amplifier that is using, that only has RCA plugs.
Yeah.
And I think for most people, that's going to be the limit, is the kind of limitations around, well, this amplifier is really, really good and it only handles RCAs, so I'm going to go with RCAs. And maybe some people have excellent balanced amplifiers, so they're a bit more, they've got a little bit more freedom in terms of what they want to use with their tonearm. But I think that's more where we might fall on the argument, is if we take a side, or if we have an opinion on this, it's that in terms of you could probably find good connections and good cables for balanced or single-ended with the Tonearm. They're pretty even match. Really, this debate might be a lot more about the electronics that it's going into, and also, whether that's whether that's going to be a wholly balanced system or not. As you allude to with what you were saying about speakers earlier. Yeah,
a couple of points I want to just say on this debate, and that is that, again, it comes down to the amp design. A well-designed single-ended amp can sound a lot better than a poorly designed balanced amp.
And vice versa.
And vice versa,
I imagine, yeah.
Absolutely. And the other thing is that all of our silver hybrid cables are balanced. So we only use coax on the what we call the upgrade cable. Everything above that is fully balanced.
And does that have any kind of issue going into a unbalanced phono or anything like that?
No, there's no issues.
Okay.
Doesn't matter.
Okay.
There is one thing I'd like to add to this little discussion, and that is that I was quite shocked a few years ago, because you have your theories blown in life, and well, I'd always known that Litz wasn't just the only answer. There's disadvantages of Litz, but it puzzled me as to why we had a cable that was using stranded wires and they weren't Litz, and which sounded a lot better. And I was trying to figure out why that could be.
Okay.
Because it was quite clear that it was way superior. And I think that it's possibly to do with the fact that when the wire is extruded, if the surface finish isn't fantastic, you've got a lot more pits, and so you probably got more contact area to make, which would cause more interference between all the various strands. So this wire, which had a very, very low grain, but it sounded fantastic, probably was a very, very smooth wire. So there's no, the rules in this game are very flexible, and I always test everything by listening at the end of the day.
Yeah, absolutely.
So on that final note.
Thank you very much for watching. Please leave your comments whether you are a complete cable denier and we are spouting nonsense, or whether you've listened to the differences yourself and you have some thoughts to add. Please like and subscribe. We'd really appreciate it. Most of the people who watch these videos are not subscribers, but keep watching. So why not subscribe? We will be back next week. I think we might actually be talking about, we might be ranking Tonearm design features. So everything that we've been talking about in these series, a lot of people are kind of thinking, we talk about side bias and it's like, this is the most important thing, where maybe something else is more important. We're going to rank what we've talked about, and also we'll love to hear what you guys have to say about that as well. So thank you so much for watching, and until next time, enjoy your music.